Okay, so perfect competition. Um, so again, we're just thinking of the most competitive, environment possible. Okay, so in this case, if you have, just think about what a competitive market would look like. Well, for one, in order for it to be competitive, we can't have very large firms, right? So in a competitive, very competitive market, you would have many, many small firms. And why that's important? Well, if there's many, many small firms, then no firm can have any influence over the price or or affect the price through changes in the quantity that they produce. Like if you think of the opposite case with something like OPEC oil, like they're not as powerful as they were once, but back in the 70s and 80s, especially, they were, they had a lot more power. And so, in those cases, they could collectively get together and restrict output so that the price goes up high. So when we're talking about a perfectly competitive market, we're not allowing for any of that. We're saying there's only a very small number of firms, okay? And so each firm then just takes the market price as given. If they try to sell for more than the market price, no one would want to buy from them. That actually leads to a second assumption about this market structure, is that everyone's selling identical goods. So that's another, if you were to come up, if I were to say, go in a room and think about some characteristics of the most competitive market possible, you would come up with these assumptions at some point eventually. One would be that you'd have to have a lot of very small firms. And second, they'd all have to be selling the same thing. And that makes it really competitive because you really can't deviate in terms of your price. Just think about a stock selling on the stock market. One stock is identical to the other stock. And so if you offered yours for sale a little more than somebody else, you're not going to sell anything, right? So it's that sort of idea. Okay, so and so we're basically saying here that each firm has zero market power. So the main assumption, as I said, there's many buyers and sellers, and so because of that, each firm is a price taker. So we're also assuming there's many buyers as well, and a homogeneous product. So we are assuming that the goods are identical, and we're assuming that there's freedom of entry and exit. And so this becomes particularly, this assumption will lead to certain things when we think about the long run. And, we're also assuming there's perfect information, that sort of thing. So everyone knows, roughly what's going on. There's no information that people can get, take advantage of to get ahead in the market or anything like that. Okay, so these would be characteristics of the most competitive environment possible. And unfortunately, in the real world, there's not too many cases. There are competitive markets, but not perfectly, competitive. So if you think of many firms you see in the real world, they try their best to avoid a competitive market. So many firms try to merge together so that they have more market power. Many firms, if you think of grocery stores, there are certain distribution arrangements. Like, I mean, if you look at the grocery store, almost all the cereal is sold by one company, probably, or maybe two. So there's very little competition in a lot of cases. And so because of that, this is sort of like a benchmark. So when you look in the real world and you see that, maybe some of these assumptions are not exactly met, then, you could put things into perspective, I guess, like you could say. But if you see a market in the real world that's fairly competitive, there's lots of people selling the same thing. There's no evidence that they're colluding together. Then, the outcome that will look here we would sort of expect to see that in the real world. And so, what's good about this perfect competition setup is that, if we actually had this, we'll see that it, will give us, it scores very high in terms of efficiency. And we even talked about this before. We kind of jumped the gun a little bit maybe, but we were talking before about the market, and we were talking about efficiency. Do you remember where you said that where the demand curve equals the supply curve, that output is the efficient level of output, because it's where, only goods, the amount of goods will be produced up to the point where there's, value to the buyers, and that exceeds the cost to the sellers, and we wouldn't go beyond. So that setup that we were talking about before is referring to a competitive market. And in fact, the supply curve, it only really exists generally like the way we draw it in a perfectly competitive market. And we'll derive that shortly. And so when you draw the supply and demand curve, you're usually thinking of a very competitive market. In theory, it would be the perfectly competitive market. Anyway, so we are going to cover, as I said, 4 market structures. So perfect competition is what we'll look at today. Monopoly we'll also look at today. And then next class we'll look at monopolistic competition and oligopoly. So here, the assumptions for perfect competition are, as I said, very large number of firms. It's standardized. You're selling a standardized product. There's no control over the price, and we said it was there's easy entry and exit. In other words, we're saying there's no obstacles. So if you think of restaurants or something like that, they really don't. There's not too many barriers to entry. It's relatively easy to enter. If you wanted to open up a dry cleaning business, you can do that. But if you wanted to open up a new cell phone carrier, like you want to open up a company to compete with Bell, Telus, and Rogers, well, there's some obstacles there in terms of the cost, right? You have to put up cell phone towers across the country. That's extremely expensive, and so in that case, there's some cost barriers. And also there might be some legal barriers there. Another example of a barrier would be a patent. So for pharmaceutical companies, they're able to enjoy a patent for a number of years. That's to encourage the, multi-billion or billions of, usually I think it's roughly something like $1 billion to get a new drug onto the market. So you need to have some incentive for companies to want to research, spend that much and risk that much money. But in this market structure, we're assuming there's no legal barriers or high cost barriers or anything like that. It's always difficult to start up a new business, right? There are lots of obstacles, but here we're saying, it's relatively easy. And so here, since everyone's selling the same standardized goods, they can't charge a different price than someone else, right? Because they won't get any sales. So there's no price competition here. Another example, I said, one example that kind of comes close is, well, it's almost very close. If you think of stocks in a very, a very popular market, each stock is identical, and there's lots of buyers and there's lots of sellers. Okay, so that's sort of the closest thing we can think of for this market structure. But there are other examples, sort of what you could think of agriculture. You can think of wheat, for example. If you're looking at the world wheat market, a farm in Canada, small farm in Canada, wouldn't, comprise much of the overall output. And so that's sort of the idea. Now that in the real world, there's lots of non-market things that impede there's different government intervention in that. So it's not perfect, but a lot of times when we give examples of this market structure, we'll say something like agriculture, or like a carrot's a carrot, so they're all selling the same good, and there's lots of people growing carrots. That's sort of the idea. Monopolistic competition. I won't go into too much detail here because we're going to go in and actually cover these in more detail. But monopolistic competition, it's pretty much the same as perfect competition, except we relax the assumption of a standardized product. And so firms here could have a little bit of control over their price because they could differentiate their product to a certain extent. Even like a dry cleaning business, you could differentiate in terms of your service. You can have a better location than another place, etc. An oligopoly, so the two on the right here, when we get into concentrated industries, oligopoly is when you have a small number of companies in an industry that dominate the market share. Okay, we'll get into that later. That's actually a very peculiar case, and the profit maximization in this situation is much different than the other market structures. And a monopoly, of course, is just one firm, so there's no competition, entries blocked. And so if you think of things like non-price competition, so that's irrelevant in perfect competition, but it's very important. And it's somewhat important in monopolistic competition. Oh, sorry, this is non-price competition. So in terms of price competition, yeah, it's irrelevant in perfect competition, and it's it's somewhat relevant in monopolistic competition, but you still don't have a huge amount of control over your price. You can only charge a different price depending on how you differ from other goods. But in terms of non-price competition, things like advertising, that would be very important here because it's that differentiation that really gives you any market power. And of course, advertising is important for oligopolies like Bell, Telus, and Rogers, but price competition wouldn't be, and we'll talk about that later. And if you have a monopoly, you don't really need to worry about advertising too much, and there's no one to compete with in terms of price. And so monopolies, you typically see them, and they usually exist for things like public utilities, electricity, and that sort of thing. You rarely see any in consumer goods or everything like that. Okay, so these are the assumptions we're making, the main ones anyways. The standardized product, easy entry and exit, and that there's many, many firms so that they're all price takers. So these assumptions would imply, in fact, a perfectly elastic demand curve. So we're going to look at an individual firm and just get an idea of what the profit would look like. Okay, and so we start out just by looking at the demand curve for a particular firm's output would look like. And we are going to draw it as a horizontal line. And that means that it's perfectly elastic. And that's just because of our assumption that we have standardized products. And so if you increase your price just a little tiny bit above the others, you're going to get zero sales. So that elasticity coefficient would be infinite, right? It's so extreme. So basically, when you draw a demand curve that's horizontal, you're basically saying this is the only price that's relevant. Okay? So if we think of the big picture, we still have the overall industry, right? So we have the overall industry. There's an upward sloping supply curve and a downward sloping demand curve. And we know that the market will tend to go towards the equilibrium price because it clears the market. It's only this price where you would have no surpluses or shortages. So in this example here, the market price is $3. And so that, again, this is the overall industry's demand curve. And this is the overall industry's supply curve. That determines a market price. And then each firm will take that price as given. And they can't do anything about it. That's what they can sell at. And they're not going to charge a price lower because they'd just be throwing away revenue because they can always just sell as much as they want at the market price. So that's why we have the demand curve as being horizontal at the market price. And by definition, these firms are very small. And so they can just sell as much as they can produce at the market price. And as much as they can produce, that number is very low by assumption. If it was large, then we wouldn't be in a perfectly competitive environment. So you can see here they even put, thousands here, but the overall market is in the millions. Okay, so that's, the basic setup. So now there's there's many other things we need to consider. This is just another example for your notes, just another illustration. So this is the individual demand curve. It's drawn at the market price. And we're going to see that the demand curve is actually going to be also equal to average revenue, marginal revenue, and the price. And it's very simple to see why. The price is constant, it doesn't change no matter how much units the firm produces. Either they sell as much as they want at the market price. So if they're always selling units at the market price, then their average revenue is equal to the price, their marginal revenue. So if they offer another unit for sale, what's their price? Well, it's going to be the market price. It doesn't change. If there's a downward sloping demand curve, that's different, right? Because if they want to increase the amount that they sell, then they would need to lower the price. But here we're just saying they can sell all they want at the market price. So total revenue we know is just price times quantity. And so in this case, it's just going to be an upward sloping line because this is constant. Remember when we looked at a downward sloping demand curve and plotted revenue underneath, we got a parabola, upside down U. That's not going to happen here because price doesn't change. It's constant. And you're just multiplying it by the quantity. And then, of course, average revenue is just going to be the price because it's always the same. So the revenue divided by Q will always equal P. P is always the same. So then you're just dividing Q by Q, which cancels. Now, marginal revenue, just to, let's explain what it is because we haven't covered that yet. It's just the change in a firm's total revenue resulting from a change in its sales by 1 unit. So how much is my revenue going to go up if I sell another unit? Now, remember, if you have a downward sloping demand curve and you want to increase your sales, you need to lower your price. But again, here we're just saying that this firm's so small, they're just a price taker. They take the market price as given and they can sell all they can at the market price. So they don't need to lower their price to get more sales. And so their marginal revenue is just equal to the change in total revenue divided by the change in Q. So it's always just, they're always going to be able to get that market price for an additional unit, okay? So that makes the setup quite simple because, the demand curve is drawn at the market price equals marginal revenue and also average revenue. So here, there's a typo here. Just switch the QD and the P here. This is the quantity and that's the price. So here we're told that the market price is $131. We could calculate total revenue and we'll get this column here. And of course, the difference between each of these is just going to be the market price. And that's also marginal revenue. So that's what the total revenue curve would look like. And again, this is your demand curve, which is the same as marginal revenue and average revenue. Okay, so we're going to talk about what profit maximization would look like in the short run. So given these assumptions, what's going on. So the firm can really only just adjust its output, right? That's the only thing it needs to decide. It can't affect the price. And so all it has to do is make a decision. What quantity do I need to produce and offer for sale? What quantity would maximize my revenue? So we could, we're going to have some hypothetical examples. And, you could think of the firm looking at their total revenue at each quantity and comparing that to their total cost. And then just finding the quantity in which the deviation here is the largest, so the difference between total revenue and total cost. But they can also do a marginal revenue, marginal cost approach. In that sense, you're looking at the additional revenue they would get from selling an additional unit, so that would be your marginal revenue, and then just comparing the marginal cost to produce that extra unit. And either way you do it, you'll get the same outcome. And we'll look at each of them. So here's a hypothetical example. You have this firm This is the quantity that they can produce from 0 to 10. So here we're saying if they produce 0 units, they're still going to have $100 of costs. And so that's why we call them fixed costs. They don't vary with output. They would of course have no variable costs because they're not making anything. And so their total cost would be 100. If they make 1 unit, they still have that fixed cost. And at 1 unit, their total variable cost would be $90, etc. And so at 10 units of output, their total cost would be $1,030, and that's comprised of the $100 fixed cost and the $930 in total variable costs. Now, let's suppose the price in the market is $131. Okay, so if that's the case, we have now all we need to figure out profit, right? So if the price is $131, we can easily get their total revenue. So if they sell 1 good, they got $131, 2, 262, etc., all the way up to 1310. So that's their total revenue. We have their total cost at each quantity. And so what's profit equal? So someone tell me what the profit is for 1 unit, 1 quantity unit.
Total cost minus total revenue.
So what would profit be? Would it be total cost minus total revenue or the other way around?
Yeah, it'd be total revenue minus total cost.
Yeah, exactly. So in that case, what would it be? 59? Yeah. Oh, sorry. In this case, revenue is less than total cost, right? So it's negative. So if we took column 5 and subtracted column 4, we would get this column. And we can see that this firm, given this data on their costs and revenue, would have a profit of $299 if they produced and sold 9 units. So their profit maximizing quantity here is 9 units. So again, when we say perfect information, we're kind of saying, the company knows its cost structure and it can, get an estimate of its demand curve. Obviously, in the real world, these things are going to be much more complicated. But again, we're just getting at a central concept here. So, okay, so that would be the profit maximizing quantity. Now, we can also do this exercise on the margin. First, we'll just look at the diagram here. So this is your total revenue, right? And if you were to plot the total cost, it would look like that. And so we are looking for the largest vertical distance between these two, right? And so that happens, as we saw, at, well, they're not going to indicate it here, but it was 9 units, right? Let me just go back to make sure. Yeah, it was at 9 units, okay? So that would be the 299. So this vertical distance here would be the profit that, at 9 units, which was the 299, right? Yeah. And then, of course, if you plotted profit, you would see that it maximizes at 9. This is maybe a little off, but you get the idea. And so there's 2 break-even points. They could, around 2 units, if they were to sell that, produce that and offer it for sale, they would break even, and they would also break even if at the much larger quantity here of around 13 or so. But those aren't that interesting of a point. We want to know where profit is maximized. So let's think about what happens to profit in response to a change in output. So this could also be determined by marginal revenue and marginal cost. If you think about it, if you think about producing the first unit of the good and you look at the numbers and you find that the marginal revenue associated with the first unit, in this case, it's just going to be the market price, so $131 in that example. If that exceeds the marginal cost, well, then you have profit. So you can just look at that. You can just keep going until your marginal revenue is equal to your marginal cost. And so at that point, we'll also give you the profit maximizing point. The thing is here, we're ignoring fixed costs because they don't matter anyway. They don't matter in terms of what quantity you should produce in order to maximize your revenue or profit, sorry. So the main rule, when we think on the margin in general in economics, you should keep doing something as long as the marginal benefit exceeds the marginal cost. Well, here the marginal benefit is the revenue you get from an additional unit, and your marginal cost is your marginal cost of producing that unit. And so if you have the situation where the marginal benefit exceeds the marginal cost, you keep going until you stop. And we can see here, this is the same ongoing example. Here, all we've done is we took the total cost that we had and divided it by Q. So we took the total fixed cost, which we know is 100, and divided it by Q. That's what this column is. Here we just took the variable cost, divided it by Q. That's what we get here. This is the average total cost. We just took the total cost, divided it by Q here. And we can figure out our marginal cost. We did that last class. So the marginal cost is the change in total cost divided by a change in the quantity. And so here, if we go from 1 to 2 units, our total cost, the change in the total cost, well, it's not here, but if we had it, we would have the change in the total cost, and then we divide it by the change in the quantity. But anyway, so we're given our marginal cost here. And so, every time we make a unit, so if we make the first unit, it's going to cost us $90. Now, if we make an additional unit and go to 2, that's going to cost $80. Okay? And we can see that that's falling. Where does the diminishing returns start to take effect here? Anyone? You don't remember from last class? What's diminishing returns or diminishing marginal product? No one remembers?
Sorry, is it between 6 and 7?
Yeah. So here, when the marginal cost is falling, marginal product must be increasing. When marginal cost starts to increase, then marginal product must start to decrease. Remember, there were mirror images of each other. So yeah, we would have diminishing returns taking effect after the 4th unit. Okay, because all of a sudden this is a higher number. So just remember that. And that actually, the assumption or the law of diminishing marginal product will result in the upward sloping supply curve that we see. But we'll talk about that in a moment. So here, if we look at the quantities in which the marginal revenue exceeds the marginal cost, we just need to look here. So these are all $131. So if I produce the first unit, well, I'm going to get $131, and it's only going to cost me $90. So that's something I should do. And you can see you would keep going until you get to the 9th unit. At the 9th unit, you're, almost perfectly, they're almost exactly the same. And you should stop at the 9th unit, because if you were to make the 10th unit, you would only get $131, but your cost would be $150. So you would want to do that. And so you would stop at 9 units. Okay? Does that make sense? And so you can see here, you would end up with the same answer as before. You would find that the maximum profit is at 9 units, and the profit would equal $299. So we're just going to use this marginal revenue, marginal cost approach. Now let's look at a diagram with all this and see how we get the profit maximizing condition. So what I'll do is I'm going to go to the diagram first, and then you have this for your study notes, right? It just gives you a summary here. One thing though that's important to point out, in fact, let me just, I'm going to put this on the next diagram. Okay. Okay, so we initially will have our demand curve, which is at the price of $131, right? So that's the market price. The firm takes that as given. Now we have our marginal cost curve. And so this first step in defining the profit is to find where these two curves intersect. They intersect where marginal revenue equals marginal cost. Now, can anyone tell me what is determined at that point? What do we know at that point?
That'd be your break even.
So this is actually the same numbers. It's the same ongoing example. So when these two curves intersect, we see that quantity is equal to 9. So what did we say about this quantity? It's the one that maximizes the profit, right? So we look for where marginal revenue equals marginal cost, because that will tell us what our quantity, our profit maximizing quantity will be. So this firm would want to produce 9 units and sell them all at the market price for $131. And if they do that, that will maximize their profit. But how do we get the profit on the diagram? We remember it was $299, but how can we see that on the diagram? Well, we need our other curves. And before I put them on, I just want to point out this, what I worked out here on the left. So profit, in economics, we just use pi as a short form for profit. So profit is equal to total revenue minus total cost, right? So your total sales revenue minus the cost that you incurred to get that. Well, that's your accounting profit. And then in economics, we're we're additionally subtracting off implicit costs. So anyways, that's your profit. So that's economic profit. But we can rewrite this as price times quantity, right? Total revenue is equal to price times quantity. And then we can rewrite total cost as average total cost times Q. If you remember, average total cost equals total cost divided by Q. So we could just put this over the other side of the equal sign. So we know that total cost is equal to average total cost times Q. And so I'm just replacing total cost with average total cost times Q. And then I can just factor out this Q. And so profit really is quantity times price minus average total cost. So here, if I look at this diagram, we can figure that out, but we need some more information. We need the other cost curve. So first of all, again, the step one is to look for where marginal revenue equals marginal cost. You get your Q star. Now we have our average variable cost and our average total cost. And so in order to get profit, we just need to look at this formula here and, figure out what the points are. So, well, you could look at this. So Q, it's Q times P minus ATC. Well, on the horizontal axis, this distance here up to 9 is your quantity, right? Your Q star. So we know that Q is going to be 9. And then at 9, we go up to the average total cost curve. And if we go over to the left here, that would give us what our average total cost is. And then we know the price. Okay, so this vertical distance here times Q gives you your profit. So it'll be this rectangle here. So that will be the economic profit. So you first find your profit maximizing quantity. And then it's here, it's 9. And so at 9, you're looking for your average total cost. And that's all you need. It's this vertical distance times Q will give you this rectangle, will give you the profit. Okay, so that would be the economic profit. Yeah, so it's pretty straightforward. So you need to remember price minus average total cost times Q. And so in this situation, we have an economic profit. Now, it could be the case that you find this Q and you have an economic loss. So this is either the profit maximizing quantity or the loss minimizing quantity. Okay, so if the average total cost curve was above here, you could see that you would have an economic loss, and we'll look at an example in a moment. So as I said, that's an example where we have profit, but firms can also have zero economic profit at marginal cost equals marginal revenue, and they could have, negative profit. So there's 3 cases. They could have a profit, loss, or just break even. So they have an economic profit of 0. Now, first, determining the profit maximizing output level does not depend on fixed cost or average total cost, but only where marginal cost is equal to the price or marginal revenue. Okay, remember, price and marginal revenue are the same thing here in perfect competition. So let's look again at our ongoing example. First here, we're going to suppose that, so in the last case, the market price was $131. Now we're going to assume that the market price is $81. So if the market price is $81 and we were to calculate profit, we would get this column here, and you can see they're all negative. So if we didn't produce anything, we're going to lose $100, right? And that's because of our fixed costs. We have to pay that. If we produce 1 unit, the market price here is actually lower than the marginal cost. So if we produced 1 unit, we would actually make things worse. We would lose, 109. But if we look here, if we, marginal cost falls, and so at a quantity of 3, we can see that if we were to produce, we would do better than not producing at all, because we're going to get, some profit. We're going to get a little bit of we're going to get, profit from just the, if this was a sandwich shop and we were to think of the rent as being the fixed cost, then here we would be making a little bit of money off the sandwiches, but not enough to cover the rent, right? So we'd still have an overall economic loss, but we are doing a little bit better. Here we're going to lose 97 instead of 100. And so if we look at the case where marginal revenue equals marginal cost, we can see that this will correspond now to the, we're a situation where we're minimizing the losses. So here we would only lose 64. If we didn't produce at all, we would lose 100. So you always go to where marginal revenue equals marginal cost, and it'll tell you whether you have, it'll be either your maximum profit at that, at the profit maximizing quantity, or it will be the loss minimizing quantity. But what if the price were, say, $71 in this example? Okay, so if the price now is $71 in the market, and we look at our profit, we can see that we might as well just shut down. Okay, so if you look here, you don't get any situation where the marginal revenue exceeds the marginal cost. Okay, so your best bet here is to produce 0. Okay, so the best way to explain this is to think about that sandwich example I was giving. So suppose you open up a sandwich shop and your rent is $1,000 a month. Now you have to pay that rent. Suppose you have a lease for a year and you got to pay that every month to the end of the year and you can't get out of it. If you start making sandwiches and the market price for them is pretty decent and you can make some money off those sandwiches, then that's a good thing. Now, if you make more than $1,000 a month off the sandwiches, well, then you're making a positive economic profit. But it's possible you might make money off the sandwiches, but not be able to cover your fixed costs like rent. Say you made $500 in profit from the sandwiches, then you're still going to have an economic loss of $500 because you have $1,000 in rent. But in this case, though, you should keep producing. You should produce a positive quantity because your loss isn't as bad as it would be if you just shut down and paid the fixed costs. But if the market price is lower than the average variable cost, in other words, if the market price that you get for your sandwiches is so low that you're actually losing money off of making the sandwiches, then you're even contributing more losses. So not only are you having to pay this fixed cost, you're also incurring losses just on making the sandwiches. So in that case, you should shut down in the short run. Okay, so the situation, there's basically 3 things that can happen. You can make an economic profit. If you do, then you should keep operating. If you make an economic loss, but you're able to cover your variable costs, then you're going to be able to have a lower loss than you would if you shut down. And so you would keep operating in the short run, but you would shut down in the long run, or exit in the long run is the correct term. And so in my example, you would keep going while that you have that lease, and then once that lease is up, you'd forget about it and you do something else. So that's the idea. So let's look at a diagram. Maybe that will solidify it a bit better. So we have our marginal cost, we have our average variable cost, and we have our average total cost. Okay? So now you can look and see if the market price is anything above the minimum of the average total cost curve, you're going to be making a profit. So let me just get a pointer here. So if the price were $150 in the market, you would go over here to your marginal cost. That would be your profit maximizing quantity. And you can see that there's a positive difference between the price and the average total cost. So you'd be making a profit. But you can just experiment. If you keep going down with the market price, if the market price is right at the minimum of the average total cost curve, then you're going to make 0 economic profits, right? And so anything above this, if it's here, you're going to go, remember, you're always going to the marginal cost curve. That's going to determine your quantity. And so you can see for any price above the minimum here, you're always going to have price intersecting with marginal cost above the average total cost. And so you're going to be making a profit. But if the market price falls below here, suppose that goes to $81, then you're going to, set that equal to marginal cost. That will determine your output. And you can see, though, that you'll make a loss because if you go up to the average total, the average total cost at that quantity is above the price at that quantity. And so you'd be making an economic loss. But because the price is above the minimum average variable cost, you're going to lose less if you keep operating. So you wouldn't shut down in the short run, but you would exit in the long run, but you would still produce. But if the market price were below the minimum average variable cost here, which is about 75, then you're just making things worse. So you would just shut down because you're starting to make these sandwiches, for example, and then you're losing money on them too. So now you got to pay your rent, and then you've also lost money at selling the sandwiches. So you should shut down in the short run and also exit in the long run. Or you just shut down in the short run and that's it, you're done. So that's the idea. Now, these are just, for your notes, this is an example of profit. This is an example of where the market price is equal to the minimum average total cost. And so there's zero economic. So there's still going to be accounting profit, but there's no economic profit. And here there's an economic loss. So if the market price is $35, I'm going to go over to my marginal cost curve. That's going to tell me my optimum quantity. In this case, it's going to be my loss minimizing quantity. At that quantity, you can see that average total cost is above the price. And so this is your loss. And again, this is what I said before. So the firm should shut down if it cannot cover its average variable cost. So a firm should produce as long as the price is greater than the average variable cost at the Q star. But we could say more generally, if the market price is above the minimum average variable cost, then we're fine. We should keep producing. But if price is below the minimum average variable cost, then it makes sense to shut down because you're at least going to not spend those variable costs, which are higher than the price, so you're losing money on selling the good. So now, you know what, I'll go to a blank. I'm going to go to a blank slide for a sec. It's not letting me. Okay, so you remember the supply curve? We had our price and we had our quantity, and it was upward sloping, right? I don't know why it's doing that. One sec. So the supply curve basically answered the question, what if the price was this? How much would the firm want to produce, right? So any point on the supply curve is just a what if sort of scenario. If the price is this, how much would the firm offer for sale? Now, if we look at the marginal cost curve, do you see any similarities here? So if the price is this here, so P0, what would the firm offer for sale? Anyone? Can anyone explain what I'm getting at here?
As much as they can.
So if the price is the market price is P0.
Supplies at a
What's
maximum.
the profit maximizing condition?
Supplies
Yeah,
at its
it's this, right? So the marginal cost curve is the exact same thing as the supply curve, right? They both tell us the same thing. In perfect competition, the firm sets price, which is the marginal revenue, the market price, equal to marginal cost. That determines their Q star. Well, that's telling us the same information as the supply curve. If the price is this, what would the firm want to offer for sale? Why is the marginal cost curve upward sloping? Anyone? Why is the marginal cost curve upward sloping? What assumption was responsible for that?
Is it that it's maximized at that point? Like
Well,
it's increasing with the supply curve, just so you're producing as much as you can.
no. So let's just why does the marginal product go up like this and then at some point start to fall? What corresponds to this from the last lecture?
That's the diminishing point.
Yep. And so marginal product will eventually, diminish because in the short run, we're assuming one of the inputs is fixed. So usually we think of labor and capital being fixed. It's just a law. Like, I mean, if you have one of your inputs fixed, then it sort of bottlenecks things, right? And so if you're increasing your other variable input, well, you're gonna at some, you're not increasing the other one, so you're kind of gonna get bottlenecked at some point. Depends on the particular production, whatever you're producing, right? And so, we have diminishing marginal returns. And remember so here every time we hire a unit of labor, we're getting more output than the person before, but we're always paying the same per hour, right? So the marginal cost will fall. And then here at diminishing returns, you're hiring another worker, paying them the same, but you're getting less than the person before. So your cost per unit is going to start to increase. That's why the marginal cost is a mirror image of the marginal product. And so the marginal cost is upward sloping because of diminishing marginal product, right? So the law of diminishing returns. So that's why the marginal cost curve is upward sloping, and the marginal cost curve is the supply curve, right? The firm sets the market price equal to the marginal cost curve. That determines what they produce. So this is the supply curve. The marginal cost curve is the supply curve. They're the same thing in perfect competition, right? Because the firm just takes the market price as given. And so the marginal cost curve is the supply curve. But the marginal cost curve is the supply curve. But where does this stop? What did we say? So when does the firm shut down? If the market price is below the minimum of the average variable cost curve, right? So the supply curve is basically zero, right? Until the minimum average variable cost, and then it's, positive. So that's the idea. So the marginal cost curve, the upward sloping portion of the marginal cost curve above the minimum average variable cost is the supply curve. I mean, we didn't really derive it. We just said, oh, the supply curve is upward sloping because at a higher price, the firm can make more profit per unit. And so, that's why it's upward sloping. But really, the reason why it's upward sloping is because we're assuming in the short run that one of the inputs is fixed, and so we get this diminishing returns. And so that's why the marginal cost curve is upward sloping. So at some point, the marginal cost is going to be higher than the price, and you wouldn't want to consume, you wouldn't want to produce any more than that. Okay. So let me just go back. So here's our general setup. And so if the price is below the minimum average variable cost, the firm would just shut down. So the supply curve here then would just be this section here. And for any market price below the minimum average variable cost, they'll just produce zero. Okay. So the firm's short run supply curve is the portion of its marginal cost curve above minimum average variable cost. Again, if remember we looked at that table and we said, well, if the price is $71, we will make things worse by keep continuing to operate because we're going to lose money off the sandwiches, right? And so it's better for them just to shut down and, you know, bite the bullet and pay the fixed cost. That's better than operating and paying more than the fixed cost in the law in terms of the loss. Okay. We could actually derive the supply curve. So here in the top, this might make a little more sense. So here in the top, we have our marginal cost curve, our average variable cost, and then we're just going to vary the market price. Okay, and remember, the market price is the marginal revenue because the firm just takes the price as given. The market price is this, then they just sell at that market price. So can anyone tell me here, roughly, just estimate what the quantity would be? You know, suppose the market price is given by this line here. What quantity would the firm want to produce, roughly? Anyone? What do? We set the price equal to so remember, marginal revenue equals marginal cost. Marginal revenue also equals the price in perfect competition. So we set the price equal to the marginal cost. So at what quantity does the price equal marginal cost here, roughly? Just anyone?
7. 27.
Yeah, so around there, yeah. It's, you know, it intersects it right here, right? So roughly probably around 7 or so. Let's see what it actually is. Yeah, you're right. Yeah, 7. Okay. And so we can now plot the point on the supply curve. The point on the supply curve is simply, you know, at a price of $3, this firm would produce and offer 7 for sale. So 3 and 7, that's 1 point on our supply curve. So now, if the market price were $8, how much would the firm offer for sale? This time the answer is right there. Anyone?
10.
Yep, exactly. So that's another point on the supply curve. If the price is 8, they would want to produce 10. And we can do that for 12, and we get this point. And so that's our supply curve. It's, you know, the exact same, it's just this marginal cost curve. But we know if the price goes below $3, then they're going to want to shut down because they're not able to cover their variable costs. So they're going to make things worse if they keep producing. So just shut down and they'll just lose out on their fixed costs. Okay, so that's just another illustration. You know, so the supply curve will be this thing here. And for anything below the minimum average variable cost, it will be 0. So we can think about just what's, you know, the different sort of scenarios. So here, the first thing you want to do, so here we're thinking about, okay, you know, what quantity are we at? Okay, so if whatever output level we're at, if price is equal to marginal cost, Again, price is equal to marginal revenue. And, oh, I just want to point out something. So, for example, here, you can see that price is equal to marginal cost here, right? But that's not the optimum. The optimum only occurs on the upward sloping portion of the marginal cost curve. Like, it doesn't make sense. Here, if you took this as your stopping point, you wouldn't, first of all, you'd have a huge loss. But if you keep moving, the price exceeds the marginal cost, so you'd want to keep going. So just remember the simple rule that you're always going to set price equal to marginal cost on the rising portion of the marginal cost curve, not anything like here. Okay. So that's why it says here, and marginal cost is increasing. Okay, so if we can answer yes to that, then we're going to think about, okay, well, is price greater than average total cost? If it is, then we're making an economic profit. And so we'd want to stay at the current output. Okay, if it's not, then that means we're making an economic loss. And so we need now to think about whether we're covering our variable costs. If we are, then we'll keep producing at the current output, but we would exit in the long run. And then if we are not able to cover our variable costs, then we're going to shut down right now in the short run. Okay. And so back up here, if its price isn't equal to marginal cost, well, you can think of just changing it until you get there. Anyway, like you want to go to the point where price equals marginal cost on the rising portion of the marginal cost curve. This is just another illustration, so you have a few different, examples for when you're studying. And so again, the minimum, the average variable cost is a shutdown point. Okay, so that's chapter 9. So that's all you need to focus on there. Yeah, I guess, we're not going to bother with the long run, I guess. We had to cut a few things out, but just as it's useful just to think about what would happen in the long run. Basically, in this type of, so since we assume free entry and exit, if firms are making profits in the short run, and remember, it's economic profit, it's not just accounting profit. So we would then assume that more people, more firms would be attracted to this industry because they could perhaps also make an economic profit. But if you think about it, if more firms come into the market to get that economic profit, then the overall industry supply curve is going to shift to the right, and so the market price will fall. And it would keep falling until there's zero economic profit. If all the firms, were making an economic loss, that would mean some of them would be closing down, which would do the opposite. The supply curve would shift to the left, and that would drive the price up and that would keep happening until you get zero economic profit. So in theory, you would, in the long run, you would expect there to be a zero economic profit in a perfectly competitive market. Okay, so let's go on to Monopoly. Maybe we'll just do a few questions to get a little bit of a break. What do you think?
Sure.
Yep. Okay, good. Okay, so I'll just open up a poll here. Okay, where's my poll? There it is. Okay, you can see the poll, okay? Okay, so the first question is, consider a perfectly competitive market. Which of the following is true of a firm in this market? Okay, go ahead. Okay, I just drew this so you have it for your reference. Okay, I don't know what happened there. Not sure what happened there. Did you guys not get a chance to respond, or let me just reopen that. And by the way, so yeah, and some of you got it wrong, so just think about this again. Okay, go ahead. So far, so good. Keep going. Oh, someone answered it wrong. Two people answered it wrong. Okay, so looks like, yeah, I think all of you got it in, right? Last chance if you didn't. Oh wait, three of you didn't answer. Two of you didn't answer. So, okay, 5 seconds. 5, 4, 3, 2, 1. All right. Okay, so A says it could actually sell an infinite amount of output at the going price. Does that make sense? Could it sell an infinite amount of output? What's the assumption we made about the size of the firms in perfectly competitive markets? They're very small relative to the overall market. So could they sell an infinite amount of output? No, that doesn't make sense, right? The firm could increase total revenue by increasing the price. We know if they increase the price, they won't get any sales, right? Total revenue is constant. Well, we saw a diagram where total revenue was like this, right? So obviously it's not constant, right? They can sell all they want at the market price. But by definition, they're a very small firm. So all that they can produce is very small relative to the overall market. But, each unit they sell is going to get the same price. So their total revenue is just going to increase linearly, right? If the firm expands output, its marginal revenue will fall. No, their marginal revenue is always equal to the price they can just get the market price. That's it. So that doesn't make sense. And then, we basically said at the beginning that they can't have any impact on the overall market, right? Because they're so small. So the product's price will be unaffected by any realistic change in the firm's level of output. We can think of this in the thousands, and then the overall market would be in the millions, right? So yeah, anyways, so E is the correct answer here. Okay, so let me just set up another poll for the next one. So in the next question here, you're given your marginal cost curve. This is the average total cost. You could just forget about this SR. It's just saying it's the short run, right? So your average total cost and your average variable cost. And it says, the diagram shows cost curves for a perfectly competitive firm. If the market price is P1, the profit maximizing firm in the short run should do what? So which one of these answers is correct? Okay, so we're told that the market price is P1. Okay, what's your answer? Sorry about that. I just reopened the poll for you. It ended a little too late. For this one, you can think of, if the price is equal to the minimum average variable cost, then if they shut down, their loss will be the same as if they produce. Okay, 15 seconds left. 10 seconds. 5 seconds. Okay, so most of you got it right. Good job. So yeah, the correct answer would be D. Although, on a midterm, if you answered E, you could probably argue, because we kind of say if it's, well, actually, no, because we usually say if the price is less than the average variable cost we shut down. We don't say less than or equal to. So in that case, it's not definitely shut down. It should be that you should produce, but you're right at the threshold there. Okay, let's just do one more question here. Okay, same diagram. And it's saying that the market price is P3. Now what should it do? So you should get perfect on this one, right? Okay, most of you got it right. So if the price is P3, then we're going to set that equal to marginal cost. So they're going to want to produce output F. Okay, so the answer is B. They wouldn't want to shut down here because if they did, they would have to pay their fixed costs, which would be more than if they produce here, they're going to break even, right? Because the price is equal to the average total cost. And so they would have, zero profit. But if they shut down, they would have to pay their fixed costs. And the amount of the fixed cost would be the amount of their loss. So that would be worse off. So that's why the answer is an A. Okay. All right. So let's go back and we'll talk about monopoly now. Okay. So monopoly. We know that a monopoly is a single seller, so no one else is selling this good. There's no close substitutes. They're a price maker, so they can charge whatever price they want, and they're going to just, consider their costs and their demand curve. There's blocked entry, and there's no price competition, and there's not really non-price competition. Like, there might be some advertising, but usually these products as well tend to be goods that have more inelastic demand. If you think about electricity, natural gas, you can't really do without. And so there's not much of a need for them to advertise in. And we all know where to get our electricity and things like that. So they might just have some public relations, messages and stuff like that. A good example of a monopoly we had in Canada for a while, but not anymore, was your telephone service. So, at some point in the past, I can't remember when, but, they've invented the phone and, at some point they had to lay copper wires to every single home in the country. That's very expensive. And so it doesn't really make sense to have multiple companies laying copper wires to everyone's house. Same with like in Enbridge Consumers Gas. It doesn't make sense to have multiple companies run gas lines to everyone's home so you can have competition because it's such a massive expense. So what they decided to do is allow one company to have a monopoly, but then they regulated it. So even still, Enbridge Consumers Gas is regulated by the government. They can't charge what they want for natural gas. And the same thing was with Bell Canada when we had them. They're the only person providing telephone service, and it's somewhat of an inelastic good. It's especially once you get used to having a telephone, it's a little hard to do without. So, you know, anyways, the government would regulate the price, so they couldn't just charge whatever they wanted. And so those are examples of natural monopolies. It's kind of only natural just to have one because of those very large costs. But of course, we know now that, you know, with the invention of the internet, you can make phone calls through the internet. There, you know, there's more substitutes. But anyways, the government actually sort of forced Bell Canada to give up portions of their lines. So basically, they allowed other companies to use the phone lines, and then they were able. So back in the day, when they first deregulated long distance, another company, I remember it was Unitel or something, they would buy in bulk access to Bell's phone lines, and then they would charge a price for long distance. But they're still using Bell's phone lines, but they bought in bulk and they could offer a lower price. So that's how they sort of artificially made their competition. But anyways, you know, we don't have Bell Canada as being a monopoly anymore. So anyways, the main idea here, in terms of a market structure, it's where you have a single company selling something. Now, if you think of what a monopolist demand curve looks like or what it faces, well, it faces the entire industry's downward sloping demand curve. Okay. And so in this case, if the monopolist wants to sell more, they have to obey the demand curve. So they have to lower their price. You know, it's just they're just facing a regular downward sloping demand curve. And so now we're going to see that marginal revenue does not equal the price. Okay. So if we think about what marginal revenue is again, it's the change in total revenue with respect to a change in the quantity. Okay, so because of the downward sloping demand curve, the monopolist must reduce the price that it charges in order to sell an extra unit, right? Just think of your demand curve. If you were here selling a particular quantity, if you want to sell more, say this quantity, well, you have to lower your price in order to do that, okay? And so in this case, the price must be reduced. So the price received for the extra units sold is not going to be the firm's marginal revenue, because by reducing the price on all previous units, so here, this quantity on all the previous units, so this is what they were originally charging. If you lower the price down, then you know you're going to lose out all on this revenue, and you're going to gain this revenue, but your marginal revenue is not going to be equal to your price. You can see that here. So this is our demand curve. Suppose that the original price is $142, and suppose that we lowered the price to $132. Well, we're going to lose $30 in revenue if we do that, because the 3 units that we were selling before at $142 are now going to be sold at $132. But we're going to gain this much revenue because we're going to sell an additional unit at $132. So we're going to gain $132, but we're going to lose 30. Okay. And so what's our marginal revenue here? So can someone answer, what's our marginal revenue from selling this additional unit? And remember, the price is $132 now. Is the marginal revenue equal to the price? What's the marginal revenue? Anyone? You just have to subtract 2 numbers.
$102.
Yep, exactly. So your marginal revenue is 102, but the price is 132. So your marginal revenue is going to be less than your price, okay? So, oops. I'll do it in this diagram here. So here, same thing. We went from 142 to 132. So everything's on here as we had in the last diagram. But if we were to plot the marginal revenue at this point, it would be 102. This is 102. And, you know, we can see that the marginal revenue will always be below the demand curve. That's another thing to point out. And it'll be below the price. The current price you can think of as being 132, but the marginal revenue was 102. Now it's really easy to see in the equation for marginal revenue. So we can write marginal revenue as the change in total revenue over the change in quantity. And we could break apart this total revenue into these two components. So the change in the total revenue here is going to be first the change in quantity times the new price, P2. Okay? And so what rectangle does that represent? The blue or the red one? Just think about it. Okay, so the quantity increased from 3 to 4, right? And this triangle here is just 132, which is the P2, the new price, times 1, right? This new quantity, the change in quantity, which is 1. So this is the blue rectangle. So this is positive, so this increases our revenue. But this portion here, which is the change in the price, we lowered it, right, by $10, and then we multiply that by our original quantity, and that gives us this red rectangle. So marginal revenue is equal to, the sum of these two. One of them is negative, one of them is positive, and then we divide it by Q. That's the blue shaded area, that's the red shaded area, and then we could rewrite that. We could just, cancel some terms here. These cancel. And so really the marginal revenue is equal to the new price plus this thing here. Now, what's the sign of this thing? How can we know for sure what the sign of this thing is going to be? What's on, anyone want to tell me what the sign of this is? Is it positive or negative? How can you tell? So is the relationship between price and quantity along a demand curve positive or negative? It's an inverse relationship, right? So if the change in the price is negative, what must be the change in the quantity? So if the price falls, what happens to the quantity? Anyone? Yeah, it increases, exactly. Yep, good. And so you're either going to have a negative on the top or a negative in the bottom, and the other one will be positive, right? So this will always be negative, and quantities are always positive. So this term here will always be negative. And so marginal revenue will be equal to something less than the price. Okay, that's all we're trying to say here. So anyways, your marginal revenue will be less than the price. So unlike perfect competition where price was equal to the marginal cost, that's not true in this context. It's not true if the firm faces a downward sloping demand curve. Okay, so in fact, the marginal revenue, so if we have a linear demand curve, do you remember from elasticity, if you look at the center of the demand curve, and then remember we had revenue plotted below, and it was like this, that was the maximum revenue, right? And then here, revenue starts to fall. So if revenue is starting to fall, what must marginal revenue be? Positive or negative? So marginal revenue must be negative. at any quantity level to the right here. So marginal revenue must be negative and coming down here. So basically you could draw your marginal revenue curve by just, taking a point here and then bringing it down right to this horizontal axis. And so this is your marginal revenue. And you could also show that the marginal revenue curve falls twice as fast as the demand curve. Okay, so the big difference here, we're still going to do profit maximization. So the monopolists will still have similar shaped cost curves because they're in the short run. There could be fixed capital, and so that's going to cause diminishing returns. So the cost curves are all going to look the same, but now the profit maximizing quantity is going to be obtained by setting marginal revenue equal to the marginal cost. In fact, you always set marginal revenue equal to the marginal cost. It just happens to be in perfect competition, you had price equaling marginal revenue. So you're still basically doing this. The steps are all the same, except, you're going to have a different looking marginal revenue curve. And remember, this is the elastic portion of the demand curve. And so the monopolist will always operate on the elastic region. And we'll see think of marginal revenue. No matter where your marginal cost curve is, it's always going to intersect with the marginal revenue curve to the left in this area here, right? And so when you go up to get the price, you're always going to be up on the elastic portion. And you can use this formula too to see where we got the 102. So the new price is 132. The change in the the change in the price was 10. Change in quantity was 1. We multiply that by 3. We get 102. Oh, this is, exactly sort of the diagram I was trying to draw earlier. Yeah, your marginal, and that's, if you were to draw your revenue here, you remember it's a upside down U, so the maximum occurred at the exact center of the demand curve. So we usually don't work with average revenue. Average revenue is just your total revenue divided by your quantity. It's the same thing as the demand curve. Don't worry too much about that. But here you can look at the calculation. So here you have your prices, your quantity. So this is just the demand curve information. You can multiply these to get your revenue. And your change in revenue is here. Now, marginal revenue is the change in total revenue divided by the change in the quantity. So this is your change in total revenue, and this is your, that change. So 4 divided by the change in the quantity. The change of the quantity here is always 10. So you're just taking each of these and dividing it by 10. And so here your marginal revenue is as stated here. And that's just this curve falling. Okay? Not too much else to say there. Let's look at the profit maximization now. So first of all, what's the first step? What's the first thing I want to look for in this diagram? What do I want to know? I want to know what the profit maximizing quantity is. So where is that? Well, it's right here. So the first thing we do is look for where marginal revenue equals marginal cost. Okay. And then we get our profit maximizing quantity. So the monopolist here would, maximize their profit by, producing this amount of Q. So what's the average cost associated with this quantity? Well, we go up to the average total cost curve and go over, and we see that it's C. What's the price that the monopolist needs to charge to be able to sell Q? Well, that's what our demand curve tells us. So we go up to the demand curve and we get the price. And to calculate profit, we do the same thing as before. It's P minus ATC times Q. And so this rectangle here represents the economic profit. Okay? So, it's the same as before, but before you just had a market price, your marginal revenue equaled your marginal cost, and then you set that your marginal revenue equaled your price, and then you set that equal to your marginal cost to get your Q. But here is different. Now, this is the industry demand curve, and you could think of this, if this was set up as a perfectly competitive environment, the demand curve would be the same, and then this would be the supply curve. Because you could think of, right now, this is the supply curve of the monopolist. If you think about, instead of having monopolists, you broke it up and had a bunch of small firms. Collectively, they should all have if you added all of their costs at each price, this would be the industry supply curve. So this would be the supply curve for the industry. That's the demand curve. And so everything else constant, if this market structure was set up as perfect competition rather than a monopoly, your market price would be here, where the supply and demand curve intersect, and your quantity would be here. And so we can see that, in theory, a monopolist would always produce less than the efficient, this is the best, right? This is what maximizes total surplus. But a monopolist will produce less, and they will charge a higher price. And we will have a deadweight loss of this triangle here. If, the only difference is whether it's a monopoly or set up as a perfectly competitive market structure. And if it's set up as a monopoly instead of a perfectly competitive market, we will end up with a lower quantity, a higher price, and a deadweight loss of this amount here. These mutually beneficial transactions won't occur. And again, so this, in this example, the monopolist is making a profit. This is another example. Okay, so I want you to tell me, first of all, what's the profit maximizing quantity?
Is it at 75? Where MR equals MC?
Sorry, the profit maximizing quantity.
5.
Yep. Okay.
Yeah.
No, that's okay. Yeah. And now, what's the price that the monopolist needs to charge, roughly, to sell 5 units?
75.
So if the price is $75, what's the quantity demanded? The quantity demanded would be 10, right?
10.
But we only want to sell 5. Because the monopolist doesn't want to produce 10 and sell 10. They want to produce 5, right? Because at 5, that's where they maximize their profit. So what price do they need to charge to be able to, what's the highest price they can charge to sell 5 units?
125.
We go up to the demand curve. So that's, I knew people were going to say this. So in order to get the price, you don't just go over here. 75 is the marginal cost and marginal revenue at this quantity of 5. To get the price, we need to go up to the demand curve and then over, right? That's what the demand curve tells us. It tells us, for how much quantity demanded would result from different prices, right? We know that we want to sell 5. And so in order to sell 5, we need to charge a price of just under $125. And so we're just going up to the demand curve. Does that make sense?
Yeah.
And so, in fact, it's 122. Now we can figure out our profit, because at a quantity of 5, if we go up to the average total cost curve, we see that it's $94. and the price to sell 5 units would be 122. So does someone want to calculate the profit for me here? What would it equal to? It's only, yeah, all three numbers are there to do the calculation.
20.
I think so. So it'll be 122, right? Minus 94. So that's your price minus your average total cost. And then you're going to multiply that by 5, right? And so 8 times 5, whatever that is. So what's that, 40? So yeah, your profit would be 40. Well, I didn't even, have it on the slide, but that's how you would get it, right? 122 minus 94. Oh, sorry, that's 6. So that's 28 times 5. Sorry about that. So yeah, that's how you calculate the profit. It's always price minus your average total cost times Q.
So 140.
Yeah. Exactly. So does a monopolist have a supply curve? Well, no. Just think about what a supply curve is. A supply curve is saying, is just outlining what the firm would produce at different prices, right? If the price was this, if the price was this, what would they want to supply? Well, a monopolist doesn't take the prices given in the market. They are the market. They just choose the quantity that maximizes their profit and charge the resulting price. Okay, so the monopolist just chooses the profit maximizing price and quantity from all of the possible combinations on the demand curve. That's it. So there's no supply curve for a monopolist. Now here, so I already did this, but they're going to do it. We have the slides. We'll just go over it again to reinforce it. So competition. So we're comparing our perfectly competitive market to a monopoly. So the level of output in a monopolized industry, as we saw, was less than the level of output that would be produced if it were perfectly competitive. And for a perfectly competitive market, we saw that the price is equal to the marginal cost, right? Because price is equal to marginal revenue. You keep doing something as long as the marginal revenue is greater than the marginal cost. We keep producing in this case. And so we stopped at where marginal revenue equals marginal cost, but it just so happens to also be equal to the price. Now for a monopoly, we're gonna, the outcome would be that the price would be greater than the marginal cost. Okay, and so we know that this corresponds to where we have maximized total surplus. Remember the producer and consumer surplus? Well, here a monopolist would charge a price higher than marginal cost. So you'll end up to the left. We'll see that in the diagram. So basically a monopoly, the marginal value to society of extra units as reflected by the price exceeds the marginal cost of producing the extra units. So again, if we think of the demand curve and the supply curve, we can think of this, this is marginal cost, this is marginal benefit. And so this whole region here is where you have your benefit, the price of the good represents someone's maximum willingness to pay for that unit. It's greater than the marginal cost of producing that unit. And so if that transaction takes place, there's value to the producer and seller. So you want the price to be equal. So the price in the market would be right here. It would be equal to the marginal cost. But we saw earlier that the quantity will be less for a monopolist. And so if you look up here, the price right off the demand curve will be higher than the marginal cost at that quantity. Actually, the marginal cost will be here. So you're not going the full way to the equilibrium is what this is saying. So it's a little better to see on a diagram, which we'll see in a sec, but you know, we would have more economic surplus generated for society if the monopolist increased its output. So, you know, we're ending up here, as I said earlier, with a deadweight loss. The quantity produced will be too low and the price will be too high. So a monopoly leads to market inefficiency. And so we can see this on the diagram. So we remember the monopolist faces the industry demand curve, okay? Based off that, we can get its marginal revenue, okay? And its marginal cost, you know, is represented by this curve here, and we know the monopolist would maximize its profits. It's the best spot for it to choose. Rational decision would be to produce QM and charge a price of PM. But if all else the same, so if we set this up as a perfect competition, a perfectly competitive market, you know, that's the demand curve for the industry. So we have that. And if we just broke up the monopoly so that we have a bunch of smaller firms, we, you know, in sum, the marginal cost curve of everyone would be the same. And so that's the supply curve. And we know that in a competitive market with a supply curve and a demand curve, the market would on its own settle at the equilibrium price of PC and produce QC. And so, you know, this price is equal to marginal cost. And, you know, the price represents, every price on here represents the maximum someone's willing to pay for the good, right? And so for all of these, you know, this price here, someone's willing to pay a price for this good, and so they value this good greater than someone's willing to provide it, the cost that they would incur, including their implicit costs. And so there's value here in this transaction, but it's not going to occur if this industry is set up as a monopoly, but it will occur if it's a perfectly competitive market. And so you get this inefficiency. In other words, you get, you know, these are mutually beneficial trades that would provide value to both the consumer and the producer. This would be the consumer surplus. This lower triangle would be the producer surplus. Okay, so again, you know, just to restate it, the profit maximizing monopolist would, you know, if it's set up as a monopoly, you will get an inefficient outcome. Quantity will be lower than you'd like it to be, and the price would be higher. This is just another illustration that you have for your notes. So, yeah, everything's the same here. Also, well, we didn't talk about the long run, but in the long run, in a perfectly competitive market, the market price will adjust so that it's the minimum of the average total cost curve. And that's where it would break even. There'd be zero economic profit. That's because of that story I told you about if firms are making a positive economic profit, well, that will attract more and drive it down. If they're all losing money, that will scare away firms and drive the price back up until they're at zero again. So there's this tendency in the long run for the price to adjust to the minimum average total cost. And that's actually another efficiency measure. So average total cost is just your, you know, cost per unit. And so you want to produce at the lowest cost per unit. And so in the long run, a perfectly competitive market will deviate towards producing at the lowest average total cost per unit. Okay, so again, this is the monopoly where you have your deadweight loss. Okay, this is another slide. I'll skip it. Just I put extras in for your notes. Oh, well, actually, this points out that the monopolist would gain this amount of consumer surplus, right? if we had just a competitive market, so if you just have your supply and demand curve, this whole thing here is consumer surplus, right? Well, if it's set up as a monopoly, this consumer surplus here would go to the monopolist. They would extract this. And yeah, this is the deadweight loss. And so is this. But this is the consumer deadweight loss. Okay, we'll just briefly talk about some barriers to entry, which could cause monopolies. So one I didn't mention before was, if you own some property and you discovered a rare metal or something like that, well, you own that, and if you're the only one that owns that in the world, you have a monopoly on that rare resource, right? Another example would be De Beers. They don't have a monopoly, but close to it, I guess. They apparently have most of the diamonds in the world, and they sort of apparently hoard a lot of them. And, that way they keep them more scarce artificially. And so that, increases the price. There's patents. Another example of a barrier would be something like before Uber with the regular taxi industry. For some reason, the government decided that only a certain number of people could provide a service like that. And so you're restricting the supply, right? If you only say there's 10,000 taxi licenses available in the city of Toronto, then only 10,000 cars can give people rides around. So you're artificially creating a deadweight loss, because many times there's, in situations where people want more, it could be Friday night, there might be demand for 20,000 taxis in the city. And so that can't be met, it just creates a deadweight loss. So luckily, we have Uber come along, and which, I like the idea of that, because I don't think the government should, there's really no reason to restrict the supply of that. You should just have proper safety checks, and, now you have I think it's really good that people could decide to drive their car and make some extra money on the weekend. And, no one's forcing the person to drive. No one's forcing the people to purchase a ride from them. They do it because there's a benefit in that transaction. So why would you not allow that to happen? So that's it. Now, of course, people who bought taxi licenses, the price of them has collapsed as a result. And, I think the government should have, compensated them for that, and then just moved into a market system and, pretend, don't do that again, because it's not very good. But the problem is, there's politics involved and all that sort of thing. So, you get non-economic decisions being made. So a natural monopoly is just remember the idea of Enbridge Consumers Gas or Bell Canada that I brought up. Well, I mean, you just have this very large fixed cost of running copper wire or pipes to everyone's home. So if you, had multiple companies, and each company had to share the market. So say this is the total market, and there's only one company, well, this will be their average total cost per unit. It'll be low enough that any price will maybe be above average total cost, and you can make a profit. But if each company only produces, say, Q, then they're going to have a much higher average total cost. And so you can imagine three companies all with this average total cost being very high. In order for any of them to make profit, the market, the price being charged to everyone would have to be much higher. So it's better just to have one company. They get these much lower costs per unit, and then you just regulate them to make sure they don't abuse their market power. So public policy towards monopolies, it's changed a little bit, I guess, in years. There's sort of more of a move towards privatization, although that doesn't necessarily mean that it's going to be any better. If you if it's a monopoly, they could be as inefficient as the government because they're guaranteed this revenue stream. There's not much of a drive to innovate and things like that because there's no competition. So it's debatable. Maybe in some cases it might be a good idea because they still have the profit motive anyways. But yeah, so there's different ways you could, respond to the main issue of a monopoly is that they can abuse their power, right? And it only really matters if the good has inelastic demand. If there was a monopoly on fidget spinners, who cares, right? Because if they tried to put a too high of a price, people just won't buy them. You can do without, right? They're very elastic demand. But when you're talking about electricity or natural gas, we need that for our house. We need it to heat our house. We need electricity. We would, if the price doubled for electricity, we would still use electricity. We might try and save a little bit, but so they could, quadruple the price of electricity if it's only one company, and, they would make a lot more money. But that's why you need to have the government regulate them. There's been some moves to make them more competitive. So like the cable company, like I guess, so in my area it would be Cogeco. They're the only ones who have, cables going to everyone's home, which you can provide the internet through. Now, the government, I guess, makes them, sell access to those cables to other companies so that they can compete with them. Like Tech Savvy, I think, is one of them. They're actually just using Cogeco lines, but the government, is trying to make the industry more competitive. And they can also, of course, regulate the behavior of monopoly. So like Bell Canada before, I think the phone bill was back in those days, maybe when I was a kid, maybe $20 or $50 a month. They weren't allowed to charge anything they wanted, but they had to get government approval to be able to increase that monthly charge. Sometimes they could turn private monopolies into public enterprises, which I haven't heard of anything really happening there in a long time, but they have done that in the past, or, they could do nothing at all. That would probably only be smart if the good had elastic demand. Yeah. So there's a bit of a trade-off. So if you think of the banks, there's an argument that they should be allowed to merge, say TD and CIBC, because if they merge together, there's cost savings, right? They don't have, a lot of things are duplicated, like their human resource department, their accounting department. You could save a lot by having one human resource department for both, just put them together. And the argument is that they could substantially lower their costs and provide better prices. But at the same time, you've also given them much more market power, right? There's less competition now, so they don't need to lower their prices maybe. And a lot of times with the banks, they're arguing that they want to compete internationally, and that's why they need these synergies. So there's a bit of a trade-off. In Canada, you can see examples where it might be true, like cereal. There's only basically one company selling cereal at the grocery stores, but I remember 10 years ago I could get a box of what are the Life cereal. When they're on sale, 10, even maybe 15 years ago, I could get a box of that cereal for $2. And I believe I bought one a month ago for $2 at No Frills. So I don't know what's going on there because it's definitely not a competitive market, but the prices seem to be very low. Would they be much higher if you had just a bunch of small companies selling? I'm not sure, but then again, you see the price of our cell phone, the monthly bills that we pay for our cell phone service. I heard that we have some of the highest rates in the world. So yeah, I don't know if it's better or worse to have a concentrated industry. My inclination is to say it's bad. But anyways, we have a competition bureau that's supposed to be, promoting competition. Sometimes I wonder if they are, but they do. There are cases, Loblaws had a big case where they were caught fixing the price of bread. So they do and they do enforce this, but I think there's more to go in terms of having more competition. But that's my opinion. Yeah, I think well, we have a little bit of time, so let's just we'll just see if we should cover this. So I mean, if you think about this, nothing's new here. This is the diagram we looked at before, where we're comparing the perfectly competitive situation with a monopoly. So if we have a perfectly competitive market, then we get this QC and PC, and it's a better outcome for maximizing surplus. But there's an incentive here. Like if it were possible that these smaller firms could somehow organize themselves, much in the way that a union organizes labor to get a higher wage, they could do something similar. They could form a cartel or something like that and try and make an agreement to, produce QM. So you would have each firm producing a portion of this, but so that it all adds up to QM, and then the price can be this, and they can, extract this consumer surplus, which will be their profit. So the thing, the idea is that, the firms would want to, there's an incentive for them to collude and get together to try and get the monopoly outcome. Of course, this is illegal though in Canada. Yeah, collusion is something that you could be in big trouble for from the competition bureau. Yeah, so yeah, you can look at this briefly, just get the main idea, but this is just saying that exactly what I just said. There's an incentive to collude. Just get the main idea for this. Now, the issue with colluding, so just get the main idea of colluding. Basically, you want to get that monopoly outcome. It's as if there's one firm now, but there really is a bunch of smaller firms, but they're all working together as if they were a monopolist. And so if they were to do that, it's not easy to keep that sort of agreement because there is an incentive to cheat, right? So if you all agreed that you're going to lower your output so that the price is higher, well, now the price is higher, there's a little bit of an incentive to try and produce a little bit more, but that would be at the expense of everyone else. So, there's an incentive to cheat within a cartel. And if all firms cheat, you just get back to the competitive level, and the whole point of it is gone, right? They also need to prevent new producers from entering, and yeah, the last point doesn't. Again, you're just trying to restrict the output, and anytime there's an agreement between many different people, you could run into issues of disagreements, right? Now the final thing we'll just cover quickly. I'm just going to check to see. Yeah, so now this is an interesting topic. So up till now, we assumed, and this is really mostly what happens, we assume that in a market there's only one price. It's the equilibrium price, right? And that's typically what you would expect, that there's one price. Now, if you remember, when we look at the demand curve, each of these prices for that particular quantity represents someone's maximum willingness to pay, right? And so that's their value of the good. So then if the monopoly, because a monopoly is the only one that can just decide what the price is, right? They are the industry. So this thing called price discrimination only applies there. So price discrimination is just the idea that the firm would charge a different price to different consumers based on their marginal willingness to pay. So if I know that this, if this person came into my store and I knew their marginal willingness to pay was this high amount, I would charge them that price. If this customer came in and I knew that his maximum willingness to pay was this, then I would charge them that price. So if you do that, there's no consumer surplus, right? The firm extracts all of the consumer surplus. Okay. So again, just, for a summary, the definition of price discrimination is just the sale of one firm of different units of a product, the same product, at two or more different, at more than one price for reasons not associated with differences in costs. So that's the main idea. So price discrimination is just, trying to charge each consumer a different price based on their valuation or willingness to pay. And so they want to do that to extract the consumer surplus. So there's different types. I don't think this textbook gets into it. Okay, so let's look at this example. So here we have a monopolist. So let's suppose that the firm keeps Q constant at QM, okay? But it's able to charge different prices for different blocks of units, okay? So we're not, looking specifically at a particular customer, but we're, at least trying, maybe because it's a little difficult to estimate, but somehow you could group your consumers and be sure of maybe the average willingness to pay in that group. So then, for example, they would want to charge the price P1 for the first Q1, okay? So remember, so the area under the demand curve above the price, so this whole thing here would be consumer surplus, right? But what they're going to do is charge P1 for Q1. So some of these consumers would still have some consumer surplus because they value it higher than P1, but, they only have to pay P1. But for all these consumers here, they would value it less. But the idea is that so here you're going to charge these consumers all of the same price. And then for P2, you're going to charge them, for this, group in between up to Q2, you'll charge them P2, etc. And so in this case, the firm's costs have not changed at all, right? But the revenues have increased by the dark shaded area. So this is now going to be revenue to the firm, because if they didn't price discriminate, they would just be charging all of them PM, right? And so this difference, P1, PM, for this group Q1, this is how much they would have got in consumer surplus, but is now going to be given to the monopolist, right? Again, so if they didn't price discriminate, the only price here would be PM, okay? And so, just looking at this first group, Q1, up to Q1, this group would have consumer surplus of this entire rectangle plus this part that's not shaded, right? That would be all consumer surplus. But if it decides to charge this group P1, well then, they're not getting this surplus, okay? And so that would go to the firm. And then same thing for this group, they would be paying PM otherwise, but if they price discriminate, they're going to have to pay P2. We know they would buy it because it still is, it doesn't exceed their willingness to pay. And then P3 of this group here. So basically, all of this green shaded area would go to the firm. Yeah, that's the idea of, so that's the idea of price discrimination. In this case, it's broken up by groups. perfect price discrimination would be where you'd be able to perfectly charge each consumer their maximum willingness to pay. And then you would extract this entire triangle. Now, what's interesting about that is if the monopolist perfectly price discriminates, what quantity would it want to produce up to? Well, it would actually want to produce up to the efficient outcome, because this would be the efficient outcome, right? And so, it would just extract all of the consumer surplus if they could just charge each consumer exactly what they need. And so if you think about being here, this consumer would be willing to pay this. It's above the marginal cost, so they would just charge them that. So you would actually get surplus being maximized in the case of a perfectly price discriminating monopolist, but all of that surplus would go to the monopolist. But at least the surplus would exist, rather than if they didn't, where you would have a deadweight loss. So that's the other important concept to just get out of price discrimination. Yeah, and that's actually exactly what's showed here. They do a simple example with just a horizontal marginal cost curve. But remember, when you have a monopolist, we know that the quantity sold will be less than the market one. And so you have a deadweight loss. Okay? And so in that case, and then you have a deadweight loss, and then also this consumer surplus goes to the monopolist. But anyways, you're losing this. This just doesn't exist. But with a perfectly price discriminating monopolist, this whole thing will exist and will be profit to the monopolist. So you get the efficient outcome, but there's just no consumer surplus. So, that's a judgment call whether you think the firm should get it or consumers, but overall there's at least there's no deadweight loss. Okay. Other forms of price discrimination are hurdle pricing. So firms create an obstacle that consumers must overcome to get a lower price. Again, you're trying to charge a price that's close to someone's willingness to pay. So any type of scheme that could make the consumers reveal indirectly their willingness to pay, then companies could try and do that. So that's one of these examples here. So consumers with lower willingness to pay, would be more, with coupons and stuff. That's really, for consumers with a lower willingness to pay, they're willing to put the effort into collecting the coupons and stuff. So, that's a form of price discrimination. So certain consumers are getting charged a different price. And only people would want to overcome this hurdle if they have a lower willingness to pay, right? So that's the idea. And then, that's a hurdle. There's other ways too, like student and senior movie prices. So students and seniors probably have a lower willingness to pay, so you charge them different prices. Regular and farm gasoline. This I don't know anything about. Is it true? Does anyone know? Do farmers get charged different prices for gasoline? Yeah, I don't know either. So, bus passes. Oh, go on. Yeah. No? Okay. Customer appreciation days, Tuesday deals at restaurants. So, some of these are ways of, even I guess, if you think of maybe like No Frills and Loblaws, it's the same company, but, there's different stores. A lot of times it's the same product, but they're cheaper at the one store than the other. The one store tends to attract people with lower willingness to pay. Although if it's the same stuff, I'll go to No Frills and pay the cheaper price. So I kind of masquerade as a person with low willingness to pay, but I just want higher consumer surplus. Anyways, that's price discrimination, and you really see this in airline pricing. They have very complicated algorithms, and I think they use game theory modeling, and yeah, they have quite a complicated pricing system, which again is aimed at trying to get you to pay your maximum willingness. And like business people are willing to pay a higher price and are more willing to, or more, they really want to, they're willing to pay a much higher price to fly home Sunday evening, maybe than the average person. So, prices are higher at you fly home on a Sunday evening rather than a Monday morning. They also, I heard, they have all kinds of information with cookies in your browser and stuff like that. And I think I heard someone say you can even, if you go on and get a VPN and go to the website, say from an American address, you'll see the prices differ. Yeah, you could probably look up ways to game that system. So yeah, so I mean, the main consequence of price discrimination is that the monopolist is going to make more money, and you'll get a higher surplus, but it'll go to the monopolist. And yeah, so that's good for tonight. That was quite a bit of material, but at least we're caught up now. And so next class, we just need to do chapter 11.